Hey everyone, with more than 20 years of hands-on coding experience, I follow some patterns and practices to design a system when I face a problem. It could be a product design, an enterprise solutions for a day-to-day usage. It could even be a startup solution or a legacy system renovation. Those are not divine strict rules that I explain now, but I will share here only my experience and how do I do it. Each slide, one recommendation, and let's begin with the system design quick decision cheat sheet. Read heavy systems. Use a cache. When most of your system operations are read, caching reduces load on database and improves response times dramatically. Combine cache and CDN, low latency needs. For ultra fast delivery, pair local caching with content delivery network. This ensures user get data from the nearest server and reducing the wait. Implement a message queue. Write heavy systems. To handle lots of writes, messages, queues like RabbitMQ or Kafka, let you process work asynchronously and avoid slowdowns. Choose RDBMS. ASIC compliance. If you need stroke consistency and transactions, traditional SQL database are your best bet for reliability. Unstructured data. Go for NoSQL. Data that doesn't fit a rigid schema like logs, documents, or sensor data is best stored in a flexible NoSQL database. Use blob object storage. Are you handling large files like videos and images? Use object storage such as AWS, S3, or Azure Blob for scalable, reliable storage of big files. Combine message queue and cache. When complex pre-computation like newsfeed, when you need to pre-compute and quickly serve data, queue jobs for processing and store results in cache for instant access. Implement Elasticsearch, trace or search indexing. High volume search needed. For searching huge data sets fast, use specialized engines like Elasticsearch or data structures like trace. Consider sharding. Have you having difficulty with scaling SQL databases? Split your database into shards to distribute data and workload, keeping performance high as you grow. Use load balancer when high availability and performance needed. A load balancer directs traffic across servers, preventing overload and ensuring uptime. Leverage a CDN, global data delivery. Content delivery networks distribute your content worldwide, making it accessible quickly from any location. Choose a graph database. Graph-based relationships. For deeply connected data like social networks, graph databases allow quick traversal and querying. Implement horizontal scaling. And more servers or nodes to your infrastructure to handle growth instead of just upgrading one machine. So scale horizontally. Optimize with database indexes. High performance queries. Think about it. Indexes let your database find data much faster, especially for large datasets and frequent queries. Use batch processing and message queues. Bulk processing. For operations on huge datasets, process in batches using background jobs for better efficiency. Rate limiters control how many requests user or clients can make, helping protect against abuse. API gateways manage route and secure traffic between your services and clients in a microservice setup. Have backups and replicas for key systems so failures don't take down your application. Replicate data across nodes or regions to avoid loss and enable quick recovery after failures. WebSockets enable two-way real-time data flow, perfect for chats, live feeds, or notifications. A heartbeat system regularly checks if nodes are alive, quickly spotting and responding to failures. Checksums validate that data hasn't changed or been corrupted during storage or transfer. Gossip protocols allow information to spread efficiently across nodes in a distributed system. Consistent hashing helps balance load and keep data evenly distributed as you add or remove servers. Spatial data structures like geohash or quad trees allow efficient queries for location-based service. In distributed systems, sometimes we choose eventual consistency to achieve higher availability. Break large responses into pages. This prevents overwhelming clients and servers. By the way, I introduced in a video also pagination with my backend service as well as with React. Least recently used. LRU. Eviction keeps your cache refreshed by removing the least recently used items first. Auto-scaling automatically adds resources during spikes and scales down when demand drops. Data lakes store massive amounts of raw data for analytics and compliance. Connection pooling manages database connections efficiently, like protobuf compresses data for faster transfer. By the way, use token bucket and leaky bucket algorithms to preventing system overload. These algorithms smooth out bursts in traffic, protecting your system from overload. And at least but not last, for the zero downtime deployments, blue-green deployment lets you release updates with no downtime by switching traffic between environments. So those are my suggestions for designing a system. If you liked it, please subscribe to the channel and leave comments. Thanks.